two sides of a triangle are given to be 5 and 13 units long, what values are possible for the third side if we want that third side to be longest? So we have three numbers, 5, 13, and x. You probably have heard that the fundamental fact in geometry is that between 2 points, the shortest distance is the straight, right? And that also feels natural. But that is the same as to say that any other trip from A to B should be longer. And that is exactly what the triangle inequality states. The triangle inequality states that if you add the length of any two sides, that should be greater than the third side. If three numbers fail the triangle inequality, then there is no triangle with side length of those three numbers. Actually, there is something more. If three numbers pass the triangle inequality, then there exists a triangle with side lengths exactly those three numbers. Actually, there is a unique triangle with those sides. So to put it in algebra, the triangle inequality goes like this. A plus B must be strictly greater than C. A plus C must be greater than B. And B plus C must be greater than A. Basically, we just said that any two sides, when we add, should be greater than the length of the third side. So the triangle exists if the numbers pass the triangle inequality. Let's just state all three versions of it, right? Any two, if we add, has to be more than the third one. So if we add 5 and 13, that has to be more than x. If we add 5 and x, that has to be more than 13. And if we add 13 and x, that should be bigger than 5. And x is a distance, so we shouldn't accept negative numbers. This is it. We just have to find all real numbers x so that all three are true. So let's see what these inequalities state. This says 18 is greater than x, but if you look at it from the point of view of x, this is where the inequality is small, it really says that x has to be less than 18. Indeed, if x is more than 18, like 20, then 5 plus 13 is not going to be long enough. So x has to be less than 18. This has to be true too. If we can solve for x, if we subtract 5 from both sides, that will say x is greater than 8. Indeed, if x is less than 8, then that number, say 7, then that number plus 5, it's not good enough to be greater than 13. So now we know that the number we're looking for has to be between 8 and 18. And the third inequality, as it turns out, is not going to give us much because it's stating that it should be greater than negative 8, which is not only included in the fact that we are looking for a distance, but algebraically too. X has to be greater than plus 8. So that this inequality does not bring anything new to the table. It's already true if these two are. For the triangle to even exist, we have to be between 8 and 18. So this is basically the solution for, well, the triangle only exists. So the triangle exists as long as numbers are ranging between 8 and 18. But if we also want it to be the longest side, then, for example, 9 or 8.2, those are in the set, they're not going to be good because they're not the longest side, right? To be the longest side, you have to be bigger than 13. And that's pretty much it. So this interval that was good for, well, when does the triangle exist? For the triangle to exist and x being the longest side, it has to be between 13 and 18. Why 13? Because in order to be longest, it has to be longer than 13. That's simple. So that's the answer. Thank you for watching.